technicians here. Yes, good. So I'm sorry you other guys are going to have to put up with me for 2 hours, but you will get your CE. What I'm going to talk about in this are the various problems that occur when training new orthodontic technicians. Talk about what to look for prospective candidates, how to test them, and what to look for when you're testing them, when you're interviewing them. Then I'd like to spend a little time, if you want, we'll talk about the basic sciences behind the materials, so you get a better understanding of how to teach people what's going on. I always like to want to know, how does this work? What's going on? So I'll introduce myself and why I'm, qualified to stand here and do this. I found out, I got a letter from the NBC that I have been, as of this year, a certified dental technician for 45 years. And I'm going to get my pen and that 2 words thing. I talked to Kate about that, and I told him that just in conversation. He said, well, we don't have an organization in Tennessee. We did, but it's kind of falling apart. And Kate said, well, call the NBC, just have them ship it here, and we'll just do that. I thought, woohoo, that'll be great. So I get to be awarded that. I counted up the other day, and I have over the years trained 27 people. So it's not a lot, but I have, kind of done it. I've been there before. I got a fellowship for my other videos years ago, and the fellowship program, they don't have it anymore, but at the time you had to do 300 continuing education hours. You had to retake the CDT test. I was like, oh, I hope I don't fail that after all these years. And you had to do some other stuff. You had to go before the board, do kind of a presentation. You had to contribute something to the industry, so my videos did that. And that was years ago. I produced that first set of videos. Can I see the hands of any people who have seen my videos in the past? All right, well, I appreciate that. I'm sorry you had to go through all that. Anyway, this is really opportune. It's just serendipity how this happened that I'm here. I just produced a new set of videos. I was going around the country speaking, and I would ask people, well, what can I do next? And the question I got from most technicians and dentists is, we need something that's like a course where you can train somebody who comes in and knows nothing and teach them the basics, the fundamentals. So that's what I did. I just finished the thing. I got it from the duplicator Monday. I got my printed thing yesterday that I can hand out. So I'm going to have a booth, and I'll be glad to tell you all about that at the booth, but we won't take time to do that now. Let's see. Because I put those first videos out, I got opportunities to go talk around the country on speaking gigs. So I spent about every other weekend for about 2 years going to meetings like this and speaking to anybody who wanted to hear about orthodontics. So I got to interact and learn a lot from people. So the one thing I can offer is I don't know everything. There's no way I know everything, but I probably know less than most of you people here. I don't know anything about the digital thing. I mean, just from what I've read, but I'm not, I'm hearing things that I've heard for the first time at this meeting. I'm an old guy. I've been around for a long, long time, but what I can bring in is that I have heard a lot of stuff over the years. I have been down the road a long, long time, and through that you pick up a few things. And so I'm hoping, I'm in a stage of my life now where I want to teach, to provide materials that help people to learn how to do what we do. And I figure I can best fit in at learning the basics in orthodontics. So that's what I'm setting out to do. I do have a lab. It's an active lab. It's really toned way, way down. I just have a few select guys I work with. There's a fellow who's younger than I am on the other side of town who's got a lab, an ortho lab, and when I get more than I want to do, I can outsource to him. And then I have a pickup delivery guy who also does clerical work, and he knows all about this digital stuff. And I am so thrilled because I don't know anything about Instagram or Twitter or Facebook or YouTube, but I am told when I come back from this meeting, I'm going to have a YouTube channel, I'm going to have a Facebook page, I'm going to be on Twitter, and I'm going to be doing Instagram. So I'm thinking, okay, another learning curve, but hey, it's what life's all about. It's fun when you're learning something. My education. I don't have a college degree, but I've spent a lot of years in college. What happened was I went to college because everybody said, hey, you ought to be a dentist. Okay. So I did all the dental school prerequisites. I got accepted to dental school at the University of Louisville. I went to dental school for about less than a semester, and I thought, I don't want to be a dentist. I really like the lab, so I quit dental school, went back to University of Louisville, studied English for years with part-time taking classes, creative writing. I thought I wanted to be a writer, but I saw that that was a hard way to make a living. But out of all of that, I did get a real good basic liberal arts and science background. So that's what I hope to be helping to share with you guys. It's a little bit larger group than to be able to go around and everybody introduce yourselves, but if I could see how many lab owners are here? Okay, that's good. Yeah. Okay, so how many people here employ people or supervise people? Okay, and how many people have the responsibility of training new people? Okay, good. We're going to be the primary target of this talk then. Okay, I want this to be interactive. I mean, I'm prepared to sit here and talk for 2 hours if you want me to do that, but you know, that gets over. So if you got anything to say, to comment on that, please just pipe in. You don't need to raise your hand or anything, just speak it out. By the way, I'm not Mr. Tyler, that was my dad. I'm Jay. Several people call me Mr. Tyler. Okay. Let's see. So, who do we train? What are the jobs that we do in the lab? Well, of course, there's obviously the lab technician, but we also have clerical people. We have a pickup delivery person. There's marketing and sales that need to be done, and there's even cleaning. So all of those are jobs for people to come in. We're going to talk primarily about the lab people, but let's just knock out some of these other things first. Cleaning person. Are there any other jobs out there that you're thinking of besides those that you run into? That pretty much covers what happens?
Maintenance.
Yeah. What is it?
Maintenance.
Maintenance. Yeah, that's right. Yeah. Yeah, things break down, you can fix. Sure. Yeah.
And nail it. Tech first.
Mail? You talking about mail?
Tech person.
Check person?
Like
Oh.
the IT,
Like the guy who's gonna teach me about all this stuff. Yeah, right. Yeah, exactly. Yeah. Yeah. Okay. So, you know, and then those could all, you know, one person can do multiple tasks. So, but all those things have to be done. Like the cleaning person, where do you find that? Well, what they do, you know, they have to do a thorough job, and they have to know how to clean. I mean, some people don't know how to clean. You know, you got to make sure they don't steal from you, and you got to be aware of OSHA standards. The clerical person, they got to be competent in math skills. They got to be friendly and pleasant. You know, if they're on the phone representing your company, they can't be grouchy. They have to have a good appearance. If you have doctors coming over, they got to look good and represent your company well. And they got to have bookkeeping experience or accounting experience. They have to be able to multitask. So that's the kind of person we're looking for there. The jobs that I've had with clerical people are like accounts receivable, accounts payable, shipping, receiving, compliance, federal, state, OSHA, and bookkeeping. Anybody have anything you want to pipe in and add to that? Clerical type person? And who do you have your clerical person do other things? I mean, do they do the cleaning as well, or are they a lab person and they integrate into the clerical side, or do you just get a clerical person?
They usually multitask. If we're a small lab, they usually take on those responsibilities. Everybody pitches in to take the trash out, sweep up.
Right.
You know, I used to have a cleaning crew come in, and I just decided, you start making cuts and looking at differences in your business model, and so
yeah. I do have a cleaning guy. I'm in a building. I lease a space in the building right now, and the guy who cleans the building cleans my lab, and he comes in every Monday at 5:30. And man, sometimes I'm not ready for him. It's a real nuisance to get everything put away and leave, for him to clean, then come back. But he does a great job. The delivery person, they need to be neat and clean, need to be pleasant. I mean, they're out there in the front. I have a delivery person who's met 3 or 4 of my guys that I've never even met before. So he tells me about it. Seem to be nice folks. They pay their bills. Need to be competent. Good sense of direction is good. It's a young person, they know how to use GPS. I had a retired guy working for me one time, and he would always, you know, I'd say, well, you go down to the 3rd traffic light, you take a right at the Shell station, and the 3rd office on the left. And with somebody with GPS, that really helps eliminate all that kind of stuff. All right, let's get down to the nitty gritty and talk about lab technicians. I've done it 2 ways, and I'm sure you have too. hire somebody who does part of the job. Maybe you got somebody and all you need is a wire bender. So you have to train somebody to bend wires, and you have to interview for that, test for that, see somebody who's competent in that. Maybe you have somebody who just, does the finish work, just put a high shine on an acrylic and make it look great. Or maybe you're looking for somebody who can do it all and just become a manager and take over. So those are the considerations when you're hiring somebody. So let's look at the parts that we actually do in the lab. What are the jobs that we do? Well, something comes in and has to be disinfected, and then there has to be model prep has to be done to it. Then we have to evaluate the case, call the doctor if there's something going on that we need to discuss. Maybe he's called for something that doesn't seem like it's going to work, so you have to work these things out. You have to bend the wires, you have to solder some appliances, you have to finish the solder joints, so there's metal finishing, pouring acrylic. With acrylic, you pour it, you finish it, sometimes you have to set screws. So these are all the basic jobs. Are there other things going on out there job-wise that I didn't mention? If you're doing Herbst appliances or complicated things, you got specific hardware that has to be dealt with. You have to be trained how to do that. So how do we find these people? How do we train them? Let's go through the jobs again. The cleaning person, that can be a commercial company. It can be your in-house staff, like Ernie's talking about, where you just have somebody working there just to do that, or you can hire an extra person. But, they all have to be somewhat OSHA trained, so they need to be at least competent enough that they're not going to get themselves hurt with some of the things you have around. Marketing and sales, you got to have a knowledge of the products. So they have to have some sales experience too. Does anybody have like a professional salesperson going out and doing that? Who's the salesperson? Yeah. Yeah, usually the lab owner is a salesperson. I had a marketing guy one time. He came in. It was great. He was a young guy. He was really enthusiastic, and we sat down. He had a degree in marketing and graphics design. I thought, man, this is perfect. He can design flyers. And he can set up a marketing program, and so we did. And he did like a newsletter and all this stuff. And so I was going to be the point man. And I found out through that experience that I was a good point man. I can go out and I love to talk about it and stuff, but I really was horrible at the follow-up. All this follow-up stuff that has to go out. You need to do a letter, go out. It's nice to meet you. And you need to send out a newsletter, and then new stuff going on, and all this sort of stuff. That was challenging for me. And now here I get ready to get into the social media thing. I think that same haunt is going to come back and get me, but hopefully I'll get over the hump and the learning curve, and I'll embrace it because it's all pretty exciting to me.
How did you find that to work out for you?
Well, it was interesting. It was really interesting. He was the son of a friend of mine, and he had a brother who worked too, and he was going to become my manager and take over. He was going to take him under my wing, teach him everything. Oh man, those kids, they were just not good at all. So I had myself in a real bind. Here are the two sons of a good friend of mine.
Right.
What do I do? And so I'm a Christian, so I take everything to the Lord, and I pray and say, Lord, help me out here. Well, lo and behold, we did this huge marketing thing, well, huge for my size, and I went out and we worked it and worked it and worked it. And you would think with that much work and any kind of marketing program, your revenues would go up. No, mine went down. So they went down just to the point where I couldn't afford them anymore. So I said, okay, you guys, I was off the hook with my friend. I had a legitimate reason not to have him employed by me anymore. And so it worked out great. As soon as they left, revenues kind of rose back up again. Thank you, Lord. Yeah, that was not good. I tell you, has anybody had any luck hiring family and friends? Have you ever done that? Yeah. Does that work for you?
At times, but
Yeah.
they will all know that I will buy.
Yeah, it's good going in there.
They know that I fired their cousins and pants. So.
That doesn't bother you around Thanksgiving or Christmas? There's no animosity going on?
Everyone, because they might not understand, but their parents understand that I'm running.
Right.
I'm come in with alcohol, reeking of alcohol, and have to go out to the doctor's office, I am firing your ass. I don't care whose son you are.
Yeah, that's good.
So,
Well, one of these guys, he would drive in, he smoked. And yeah, that's okay. I didn't know that until after I'd hired him, but I don't know if that made a difference or not. So he would go back in the parking lot, sit there and smoke cigarettes. He was supposed to be there at 8 o'clock, and we had one of those time punch things where you stick your finger on there, you know, and it would digitally hit the time clock for you and all that. So he would wait till right at 8 o'clock. He'd be out there about 10 or 15 minutes early and just smoke cigarettes. And then he would come in right at 8 o'clock, hit that thing right on the dot. Then he'd go to the bathroom for about 15 or 20 minutes. I'm like, oh man, I like a good solid work ethic and all that. So I looked it up online. You know, what's our responsibility for that bathroom break thing? And my goodness, you're kind of, there's nothing you can do. You can't keep people from going to the bathroom. And what I read is like a standard thing was like, if they're going for like over 20 minutes at a time, you can maybe say something, but short of that, from what I read, kind of stuck in the mud. I mean, that's so, I don't know, just not a good attitude. The clerical person, I've never hired anybody who wasn't savvy in bookkeeping for that position. I have an accountant who does it now, and it's nice that I don't have to hire anybody. He just handles all that stuff. So that works for me. I have had people. I had a legal secretary one time. The biggest lab I ever had, I had 8 people. And so that's as big as I ever got. And I tell you what, now it's just me. I'm the only lab guy there. I have a pickup and delivery guy who does the invoicing and statements and all that stuff, gets things ready for the accountant and all that. And he's going to be my social media guy. And then I have, I think I mentioned a fellow that I outsource to if I get too busy or get things in I don't want to do. So that's all the work I want to do at this stage of my life. Delivery person, who do I look for there? I've had different types of delivery people. I had an older guy. He was retired and he just wanted some part-time work. That worked out pretty well, but he couldn't use the GPS. He didn't know anything about Google and all that. This young guy is working for me now. He's a student. I have to work around his schedule. It's kind of a nuisance sometimes. Gets me down to the lab early in the morning sometimes because he's got to grab them and run off and do the deliveries and go to class. I like it better when his classes are in the morning and then he comes to the lab in the afternoon and does a run. That's kind of nice. But I don't have to tell him anything. I just give him the doctor's name. He gets on with Google and finds out where they are and just he takes care of it. It's wonderful. You could have a part-time person, like I have, or you get a full-time person, depends on how big you are. All right, let's get to the nitty-gritty here. Let's talk about the lab. Where do you look for lab technicians, orthodontic lab technicians, and how do you test them? So what I look for are people who already have a good set of hands. Duh, it's obvious. People who are already employed using their hands. That's a good start. So who are these people? I'll throw some out. You guys add to it and learn from each other. Construction people. These are kinds of people I've hired and I've had different levels of success with them. Construction people, mechanics, nail salon people, hair salon folks, dental technicians and other specialties. I've been through a lot of those, and just because somebody's a certified dental technician in Crown and Bridge doesn't mean he can bend wire, doesn't mean he can polish acrylic. You have to test them for all these things, even if they are. Dental assistants, anybody's been working in the mouth, working with their hands, at least they know the anatomy and terminology and stuff. Because, we have a language, we have our own language. When you say put a spring on the mesial to distalize that molar, they need to understand what you're talking about. Dental hygienists, they probably make more money than you're going to pay them already, unless they're sick of dental hygiene. Artists, I've hired people from an art school before, a trade school. That's worked out pretty well. Like somebody who does sculpture work or arts and crafts people. There was a lady one time worked for me. She made jewelry. she knew how to bend wire already. It was amazing. It just a little sidestep from what she was already doing to bending wire. And once she learned the anatomy and terminology and everything, she was great. So we've already talked about family and friends. Oh, this guy up across town from me who does my outsource work, his whole family works for him. He's got 2 sons. He's the main technician guy. His dad was an orthodontist who died. His mother does pickup and delivery. His wife does the bookkeeping and clerical and everything. I mean, it's a whole family thing, and it just thrives. It's a great thing. I didn't have such good luck. I hired my mother-in-law one time. That was awkward. She did bookkeeping. Not so great. Okay, so when you're interviewing people, what are some of the things you look for? The first thing I look for is like appearance. You know, you're coming for a job interview. How are you dressed? I used to have my lab in a small country environment in Tennessee, just west of Nashville. And the county, it was called Hickman County. It was 20% illiterate. And so I would do the cattle call, which I would just put an ad in the paper looking for a dental technician. Oh my gosh. I would get all these people and I could just go in there and glance and just tell, I'm not going to hire you or you or you or you, just from the way they looked. I mean, just the way they dressed and came in. So that was a real consideration right off the bat. And their attitude. Are you upbeat? You're excited? Are you leaning forward when you're talking? Do your eyes kind of get wide when you talk about possibilities? What's going on with your attitude? And posture, even something as simple as posture. Just slump down and checking the references. I found that was huge. Anybody's really good when they're talking to you. But if you check around, check the references, and they're probably going to say good things about it too. But I was surprised at people who would say, oh, yeah, he would give me a good reference, especially former employers, but even their friends. I was amazed at how some of the friends would stab them in the back and tell things about them. So it's really good to check references, even knowing that they're probably going to tell you something good about them, but it might surprise you. And find out about their interests, their hobbies, what they like to do. If their hobbies involve a lot of hand skills, that's a real plus. It's really nice. Check their resume, call them up, call these people. And then one of my favorite things that I learned from a guy, he was an executive in a business. He was like an upper management guy, and he was telling me about, we were talking about hiring people. And he said, this is my favorite thing to ask people who come in looking for a job. Real simple, just say, tell me something about yourself. And just leave it open. And a lot of these other things will appear, what's their attitude, what do they have to say, and do they talk a lot about themselves? All right, testing. There's a general aptitude test I used to give. I forget the name of it. I was going to Google it before I came down here. I forgot to do that. I apologize, but since we have the power of Google, it's really nice. You can go in there and just go general employment aptitude test or something like that. You'll probably get a plethora of opportunities to download. The one I used, it had just very basic math skills questions. It was about 20 questions. And it just tested your just general basic knowledge. I mean, if you had gone not even through high school, but just got into high school somewhere, you would be able to pass this test. And when I lived in that town that had 20% illiteracy, it was great. That's when I discovered this thing. First thing I would do on the cattle call is just get a test out, and I would have people look at that and go, I don't do math, and they just leave. So you don't do math? How do you balance your checkbook? For the specific tasks, if you only need somebody to do 1 or 2 skills like wire bending or trimming or polishing, the real simple thing for me, once they pass the general aptitude test, and I think that they're a good candidate, I want to test their hand skills. If I just have I had a lab that I did do the specific things. I had one person who was great at polishing acrylics. I mean, she could just take an acrylic and just make it look wonderful each and every time. Consistent thickness and all that. She had it worked out. She just had an knack for it. Could not bend wire with a tooth. So then I had another person who was a great jeweler lady. She bent wire like crazy. She could just draw a pencil line, and it didn't matter what it was, she just put it right on the mark. It was great. Didn't understand function. She had a hard time in the conceptual part of the function of the thing, but she could put the wire where you wanted. But she couldn't polish an acrylic with it too. So between the two of them, add them up, you had one good technician there on the retainers. So what I did on that was I would isolate what I wanted done, and I would just show them, and then I'd sit back and watch them. And that just tells so much. And that's hard for me to do. I'm not a very good person. I like to do this. I like to teach. I like to make videos. But to sit down one-on-one with somebody, I have to sit on my hands because I want to go, no, we do it this way. And so whoever's training has to have that ability and that patience to be able to watch somebody without, wanting to jump in there and take over, and then and show them, and then watch them do it, and then maybe show them and watch them again, back and forth a few times. You get a real good idea if you're patient enough to find somebody who can do that. All right. Now this is huge. I learned this years ago. Has anyone ever heard the Myers-Briggs personality type indicator? It was kind of a big deal years ago. I think it's still kind of a big deal. What it does is it tests your personality type through a whole series of questions. I took a 2-day class on the thing. It was really intense. I learned a lot about myself, and learned a lot about my wife, and we're no longer married. What it does is it tests you on 4 different areas. Whether the first area is whether you're an introvert or an extrovert. And an introvert, somebody who doesn't like to be messed with too much. An extrovert's the life of the party. And then it tests you on whether you're an intuitor or a sensor. And a sensor is somebody, you say something to them and they just take that sensory data and they go with that. An intuitor, you say something to them and they walk away and they go, I wonder what they meant by that. Sensor doesn't do that. And there's a feeler and a judge and I forget what the other side of the feeler is. Oh, a thinker. Feeler and a thinker. And the feeler is all emotional, and the thinker is just pretty much cerebral. Then there's the judger and perceiver. And a judger is able to walk into a restaurant, look at the menu, and go, I want that. He's done with it. And a perceiver will go, I can't make up my mind. So what these tests do is they determine out of those 4 things where you are on some kind of a continuum on each of those 4 categories. And it's really important in that if you know a person that you're going to be working with, if you know their personality type and you know your personality type, there are things that you can read that will show you how best to react and interact with this person and get most out of it so that neither one's offended and the work sets up best for the person for the task that you're assigning. There's a book that I highly recommend. It's called Please Understand Me, and it addresses this. It has a pared down version. It's called a Keirsey Temperament Sorter, and it's an abridged version of the Myers-Briggs, and it has a little test in the back with about 20 questions, and from that you can deduce approximately what their personality type is. And then it also has paragraph after paragraph in there of, well, if you're this type and you're that type, these are the things you need to look for. Really, really well done book. Please Understand Me. It's a good book. So what that means is like, if you have the personality type where you, say your personality type is, if you're told to do something, or let's say you have a schedule, you plan to schedule, you're going to do A, B, and C. So you're doing A, you're doing B, and you're doing C. You don't want to be interrupted. You want to go down this process. And then someone else has a personality type where maybe they're the kind that's driving down the road going from A to B and they see a sign that says, go look at this. And they go, oh, let's go look at that. But the person who's wanting to go from A to B doesn't want to go look at that. It annoys them. So it goes through all these different kinds of situations that you might run into with a person, and you learn how better to do that. So with that type situation, if you're a go from A to B type person, or if your employee is an A to B kind of person, and you want to interject something in between there, they do a thing called signposting, where you just suggest, hey, I want you to think about doing this. I'll be back in 5 minutes. Gives them time to process it a little bit before you just go in and just, interrupt the world. So book, Please Understand Me. It's a wonderful book that addresses all that sort of stuff. So learning that, I've learned a lot. I'm not good at it. I'm terrible at it, but I've learned at least how to kind of read people on how the personality types is and treat them the way they want to be treated. It seems to work. Now, another thing I did with my life as I get older, I started looking around thinking, you know, I've got it's all this work to do. My gosh, all this work, what do I do? Well, I gotta, you know, people come and say, well, you need to hire somebody. You need to hire somebody. Well, who do I hire? Do I hire a technician and train him? I don't really want to go through that again. I got a sweetheart little deal going on right now. I don't want to interrupt it. So I started thinking about my life. Well, what is work? And I wanted to define what work was. And, you know, everything is work. It's all work. So so it's all about time management. You know, managing my entire day. So then I started thinking, no, wait a minute. I don't like doing handyman stuff. I just don't. My wife has this huge list of things that need to be done. The honey-do list. More do than honey, but it's there. So I decided I'm going to hire a handyman. So he comes in and does all these handyman things that I used to do. Gives me more time. I got tired of cutting the grass. I don't even own a lawnmower anymore. I have a service that comes in and takes care of that. That was easier than hiring a technician. The outsourcing, when I get more work done than I want to do, I can send it to my outsourced person. So I just started, and it's just made my life so much easier. So that's something that we can all do as lab owners and managers and people who hire people. If you're in that situation where you want to free your day up, you just start looking at your whole day and work and seeing what you can do to eliminate this, that, and the other. All right, has anybody got any comments, questions, complaints, anything about what we've covered so far? Before I get a drink of water here. No? You want to hear me talk for 2 hours, really? All right. Let's talk about science. The science of the materials we use. These are some of the things you'll be teaching your prospective employees. Generally, your employees, if they're going to be like in a management position, let's just say we're going to not teach somebody how to do one thing and leave them at that. If you know, they can start that way, and then you can move them over to this, and then you can move them over to that. Pretty soon, over 3 or 4 or 5 years, they'll learn how to do everything. I've had people do that with businesses I've had in the past, and that works out well if they stay with you long enough. But if they're going to do that, then there's some basic sciences they need to learn along the way. Generally, the etiology of malocclusion needs to be something they understand. And etiology is fancy word for cause. What causes malocclusions? And for most of the malocclusions I've seen, I'll just say a lot of the malocclusions that I've seen are a result of premature loss of the deciduous posteriors resulting in mesial migration of the 6-year molar, the first permanent molar. And so they need to understand the eruption sequence and need to know the importance of keeping those deciduous posterior teeth in place and healthy until the bicuspids come in and replace them. I'm sure you've all seen molars drifting forward and bicuspids, and then especially cuspids crowded out where they're sticking up like fangs. And so it's just good to understand the basics of it. They need to know about anchorage, because if you're putting an appliance in a mouth, you got to grab a hold of something, and when you're pushing on something else. In orthodontics, we rarely don't push on something. We lock onto something and we push onto something. So they need to know the basics of anchorage. They need to know about root surface area. Back in the old days, the measured root surface area, they used to take roots of teeth, they would dip them in wax, peel the wax off, and actually measure the surface area, so they would find out what the root surface area is. So if you got a molar that you're hooking onto with like a band and a wire soldered to it, it goes up, and then on that wire you have a spring that's pushing on an incisor, you could dip that wax, if you were able to dip the root in wax of the incisor in the molar, and you spread it out, and you say, hey, there's more root surface area on the molar than there is on the incisor. So, there's equal and opposite forces, so it just makes sense that the molar, of course, it will have some force against it, but it's going to be the anchor system onto which the incisor is moved. So they need to know this sort of stuff and think about that. They need to know things like force vectors, like if you let's say you got a tooth here and let's say a bigger tooth here, and you want this tooth to go this way, that far. Well, there's two components to it. There's this component and this component. And that is the resultant of it. So that would be the resultant force. It's just, basic physics. It's not really that important in the practical aspects of it, but it's just good to have a basic science background on what you're doing. So they need to know about the materials themselves, like wire. Where does wire come from? How's it made? What happens when you get wire and you bend it? What happens when you get wire and you heat it? They need to know about that. So let's just talk about wire for a minute. If you know this stuff, it'll be good review. If you don't, it should be enlightening. So most of the wires that we use, they're made of nickel and chromium. And it's an alloy. An alloy is a metal made of two elemental elements, two or more elemental elements. Now it'll have some trace elements in this as well besides that. So what they do is they either dig up the ore and refine it and pour it into a mold, or they recycle nickel and chromium and pour it into a mold, and that mold produces a billet, and a billet is like a cylinder of this nickel and chromium. Now, the nickel and chromium don't really react together. They're just poured together. They're just melted together. They're fairly stable on their own. Nickel, well, you can take a nickel, make a coin out of it, stick it in your pocket. Chromium, it'll be, pretty and shiny on your trailer hitch. It's stable. It's good by itself. And when you heat them up, you don't really react the two together. You form what's called a grain, and metal becomes like a crystal, kind of like salt or any kind of crystal. It becomes a grain system, and these grains, they're just all over. The whole thing is just full of grains, and each one of those grains will have both nickel and chromium in it. And between these grains, there's a bond that holds that grain together. It's a grain structure. So what they do to make wire from a billet, so they dig it out of the ground, or they recycle it, they pour it into a mold to get a billet. And then the way they make wire, get a different color here, is they push this thing through a die, got a hole. They heat this up, and they have a push rod here, and it pushes it through this die, and now it squirts the other side, just like squeezing toothpaste, comes what they call a rod, and they're about that big around. The billet, I saw this one time. I was at a place where they were doing aluminum extrusion. They were making, aluminum. Well, here's some right here. It's like where they make the casings where windows and what have you are. They starts out with a billet. I haven't been to a wire mill. I haven't seen them make wire except on YouTube, but I did see this. And they would have this aluminum billet come out, and it was at a certain temperature. It's all, engineered. The piston would come in and push it through this die, and out the other end, extruded, would be this shape, and it would just squirt this long thing out. And these guys would get it, and then they'd put it in this thing, and it would cut it to size, and then it would assemble, and it would go out as a window frame or something. So to make wire, they do this, but it comes out as a rod on the other end. Now the rod goes to another factory, and they heat it up, and it goes through yet more of these to reduce it and reduce it and reduce it. So it goes through a series of these things until you get the right size wire you want. So that's how wire is made. I thought that was interesting. Okay, so once you get wire, then you got these different properties. And there's really only two properties that we deal mostly with, and that's elasticity and tensile strength. Now, elasticity is inversely proportional to tensile strength. That means if you've got real good elasticity, you probably don't have good tensile strength. If you've got real good tensile strength, you got poor elasticity. So what does that mean in practical terms? Elasticity is the ability of a wire to be bent and not break those grain bonds. basically, that's all it is. So if you got a wire, and I'm just gonna draw little lines here. This is representing lots of little grains. They're all bonded together, little bonds between there. So if you have a wire with a lot of elasticity, that means you can bend this wire and let it go and it comes back and you haven't disturbed any of those bonds, they're grain bonds. And if you bend it more and it comes back, you still haven't disturbed them. The point at which you bend it and it no longer goes back to its original position is called the elastic limit. And what you've done then is you've actually somewhere in the wire shifted it hasn't broken it apart, but it's just shifted. Those bonds that were holding the grains together, they just kind of shifted a little bit. They're still strong, they just kind of bend a little bit. So it's kind of a little kink in the wire. You can't really see it unless you make that bend. So you're holding it here and you bend it like real strongly right here. You might see, the shift. You'll certainly see bend, but you might not see the little shift in it. But you will never, at that point, be able to return it to its original position. It's a bonded shift. You can't reshift it back where it was. So, but you can bend it back and get it kind of straight, but you can never get it perfectly straight again like it was when it came out of the die. So that's what elasticity is. Now, why is that important to us? Well, if we have a wire that's going to be used as a spring, we want something that's got a high elasticity to it. We want something with a really high elastic limit. So we want it to spring. If it's something like a labial bow on something that's a finished ortho case and the teeth are not going to be moving, it's not going to have action to it, then it doesn't have to have such an elastic limit. It doesn't have to have so much elasticity. Now, with a high elasticity, it's harder to bend the wire. It's a spring hard wire. So you'd like to have a little softer wire to bend as much as possible, but you can't always use a softer wire. So depending on the case and what you're using it for, will depend on how much elasticity you need in the wire. And this is getting boring, I know. So you guys pipe in and ask me anything you want, or I'll keep talking. Okay. All right. So what's the other thing then? The other thing is tensile strength. What is tensile strength? Well, how do they measure tensile strength? We'll put it in practical terms. The way they measure tensile strength, and I saw one of these things one time, they'll take a wire and there's a machine, grabs both ends of the wire, and it starts pulling that wire, and it's measuring it. It's got a gauge up there. It tells how much force. And the point at which that wire breaks is this measure of tensile strength. Now, what you've done is you've actually ripped that bond apart, that molecular bond that's holding those grains together. Imagine how strong it is, and bam, it just rips it apart. So those are tight bonds. And the bonds are like magnets. They stick grains together like magnets. So why would we want tensile strength? Why would we want something with a high tensile strength? We don't measure tensile strength in the lab, but we can measure the relative strength of wires. The way we can do that is we can hold a wire like an 028 and a plier and bend it 90 degrees and back and back and back and back and back and back, and it will finally break. If you count the number of bends, that'll give you a rough, it's not pulling it apart, but it gives you a rough idea of its strength relative to another wire. You put another wire in there that's got a higher tensile strength, you'll bend it back and forth several times before it breaks. And so that'll be a way that you can actually measure the approximate tensile strength or relative to other wires. If you got a spring hard wire, you'll bend it back and forth just a few times and it'll break. So you can't have both. It'd be nice if we had a wire that had tremendous tensile strength and tremendous elasticity, but it's just not going to happen. So we have to kind of think about which wires to use for the different applications. When bending wire, you're teaching someone to bend wire, it's kind of interesting to me to just give somebody a wire and a plier and a cutter, and I'll usually ask them, like, cut that wire into 4 equal pieces. It's always kind of fun. And, that gives you a sense of how their spatial perceptiveness is. And you can put the wires down and see how close they came. Some people just have a sense for it. Some people just, got one this big and one that big. And you wonder, how did you arrive at that? And then how to hold a plier, how they hold a plier. If they're just kind of having trouble with it, you're going to have to teach them some people just have a knack for it. They can pick a plier up and just grab a wire and just start working with it. And think, okay, that's not gonna be so bad. I'm gonna be able to teach this person pretty easily. At the, when you cut the wire, you have to teach them to hold the loose end so it doesn't go flying across. One time we had a balloon and we used to try to hit the balloon and break the balloon with the flying wire, but I didn't say that. OSHA approved safety glasses, most of must. All right, no questions, anything? You want to know about anything? I don't know anything, but I have a little up here, but anything I got, you're welcome to it.
When you soldered that wire, was that wicked?
What's your name?
Paul,
Paul. Great segue into my next note here. That was perfect, Paul. Talk about soldering now. Okay, where does solder come from? How do you make solder? Same way you did wire. Well, it is a wire. We usually solder with wires, and it's got a lot of silver in it, and it can have nickel in it and other things in it, but it's a lot of silver. And why do we use silver? It's because it has a low fusing point or low melting temperature. So it's going to melt long before, what you're soldering against is going to be a nickel chromium type thing or a stainless steel. Well, that's a misnomer. Steel comes from iron, which is a ferrous compound. They put carbon and iron to get steel. So we don't use steel. So if you're buying stainless steel wires, it will rust. If it's got, the way they get stainless steel is they put chromium in the iron that's got the carbon in it, and they put chromium in it to get stainless steel. But still, it's a ferrous metal, and it doesn't need to be worn out. So what you're dealing with is really nickel chromium in most cases. Okay, so the solder, you make the solder like a wire, and it's important to prepare the solder area. So how do we do that? I just take a stone and just put it on low speed and rough it up. Rough up the band if it's going to be like a lingual arch, rough up the wire. And what I like to do is I like to taper the ends of the wire. I like to completely encase the solder, the wire with solder. And I don't like to have the wire sticking out of it. I don't like to polish the solder down that exposes the wire. All it does is it invites seepage. Now there's things in the mouth like salivary amylase and some other things that are corrosive, and they can actually start eroding. Since that silver is a soft metal, it can start working its way in between the silver and the wire and start eroding it, and that wire can break loose from the solder joint. Solder joints are really good, even if you do a bad job, but I have seen some break and give way. So I figure, why not just encase the whole thing? Have the end of the wire tapered so it can get solder around the end of it. Have the whole thing covered so when you polish it, it doesn't expose the wire. And that's, to me, really the best way to do it. In fact, the ideal solder joint, in my opinion, like if this is a molar and this is a band, and we're going to do like a lingual arch or something, and we're going to put the wire right here in the middle. Okay, let's look at it from the other angle. Okay, here's the wire right there. To me, the ideal solder joint will fully encase the wire and just kind of taper down so that you have where it slides under the free gingiva, plenty of room. It's not a big blob down here. Hard to do. Now, what happens if you solder, you got kind of a blob? Well, you got two choices. You can leave the blob and polish it. You'll probably still have a good solder joint if you didn't overheat it. If you overheat it, you get bubbles. When you grind down, you get surface porosity, and you can't get rid of it. It's there. So if you get a blob and you have to trim it, that's what you take a chance on. If you get an extremely good solder joint, and I'll talk about what that means, then you can probably cut it down and you'll be all right. You won't have the porosity that is typical in some solder joints.
We had a metal finisher. She was a technician that graduated from a lab school, and she was grinding our solder joints too fine.
Mm-hmm.
And so then she was exposing, a crease
Yeah.
of the wire and that. And some of these came back, and I took photos of these because I was, you know, I'm embarrassed about it, but you know, this is what you got to teach
Yeah.
off of. And the wire would come out perfectly.
Mhm.
And then, so then I started looking at the wire too, and I'm, you know, and it goes back to, you know, soldering 101, where, you know, you have to roughen that up because you have two highly polished surfaces and you're trying to put the solder around it, and it's not going to work. Eventually, the mouth acids and everything that goes in there is going to loosen that up. And,
Right.
you know, it's amazing to see it just come right off, you know, the band.
Yeah.
And that's not a very proud thing to, you know, when you're a little lab owner and you're looking at that, that's not a good thing. You know?
Yeah. Yeah.
So,
Well, let me ask you, I don't know anything about laser welding. That seems to be a thing now. I read a thing that says, are you tired of soldering your appliances? Buy my laser welder gadget. And I kind of understand what it does. Is anybody using laser welding? Okay. Can you explain that to me? You have a laser beam that goes in there and kind of melts the metal together?
They use,
Okay.
well, you will have to have a bend, so that it's flat, it won't flat.
Right.
And then you will go down, you have a set.
Oh, so you go down it. It's not like a spot welder, huh? You actually go down?
Well, I mean, no way, you will, it can, no way, you use it as a spot well, which is, you do one as many spots as
Right.
possible.
Yeah.
And then, it uses the together, so that it's essentially one.
Wow. Okay, so you're actually like welding. I mean, welding melts metals together. So you're actually, that's what it's doing?
Yeah, it's a lathe, so
Yeah.
welder, or they will have full sort,
Yeah, what's the difference in those two?
I don't know.
Okay, I don't either. Anybody know the difference between a pulse welder and a laser welder? Is a pulse welder like a capacitance discharge welder? Is it a capacitance discharge welding, or is it as opposed to like resistance welding? Resistance welders are like the things you used to get them from like Rocky Mountain or something, and they had the little phone dial thing with the little prongs that came together, and you'd stick it in there, and you'd dial, and give it like 3 pulses or however many times you dialed it. And it was like a transformer in there that put a high current, low voltage high current, and it would just, the heat from that would just, you know, weld it together. Capacitance discharge, a capacitor is an electronic apparatus that's really 2 plates close together, and they have an insulator in between them. And you can get these capacitors that are these cans, and it's just like this metal thing is wound and wound and wound. And you know, if you unrolled it, it would be this huge long thing. It's 2 metals with an insulator in between it. And what that does is you can put a DC direct current charge on it, and it will hold that charge. So you charge these capacitors in this welder, and you would get those prongs there, and then you would hit a button, and it would put this big high voltage bang pop into that thing. And it was just a different way. Instead of high current, this in low voltage, this was high voltage, low current. It's just a different way to do it. And I knew a guy who he was in Georgia, and he would take a Unitech back when it was the company Unitech. I think 3M bought them. Is there still a Unitech these days, or did they just totally branch it out? Okay, that's how old I am. And I go back to the days before bonding. I mean, they used to put metal bands on incisors. I go way back. So and the first liquid separator I saw was called foil substitute, and it was called Alcoat, I think. And so yeah, I'll go back to the days where you varnished metal and pour it that way. Oh my gosh. So
Jay, I got a request just last month for a central band with a bracket.
Really?
Yeah, and I was blown away. I said, how does this guy even think that I have these? I did.
Wow, Ernie, I'm shocked you didn't
I
have
had
that.
I had him, and I said, but I was blown away. I was talking to my manager. I said, call him up, and what makes him think we even had these in stock? I just started laughing. She goes, no. And yeah, it's funny. It's just so odd that I had them.
I would have to take a bicuspid band and pinch it on the lingual and fold it over and
I even have those pliers that make those too.
Yeah.
I even still have band, little band whatever it's called, sheet bands or whatever.
Oh, yeah, the matrix
band
band material.
Yeah, matrix material,
Yeah.
make own bands.
Yeah, I used to have some of the, I probably still have some around, but boy, you look around the lab, when you've been in business as long as I have, you think, oh, I don't use that or that or that or that anymore. Things change. Wow. Okay. Back to your question, Paul, on heat control. What happens when you heat a wire? What was your question again?
About weakening.
Weaken it, yes. So if you take a ferrous alloy, like a, well, let's say like a bobby pin, is that what you call it? You pin your hair, ladies, okay. So if you take one of those, that's an iron product. And if you heat it and get it like red and then quench it in water, it makes it real brittle, it'll break. And how, if you like quench it or you let it, bench cool or whatever, that affects the temper of it. But nickel chromium is different. You can heat a nickel chromium wire and quench it, and it just takes all the spring temper out of it. So, or if you just heat it too much and just let it bench cure, it'll take all the temper out of it. It will become, say it had a lot of elasticity and lower tensile strength, it kind of goes like that all of a sudden. Where you could bend it back and forth several times before it broke, but you bend it and it just pretty much stays there. It doesn't has practically no elasticity to it at all. So the way to avoid that when soldering is to use a heat protected compound. I use a product called Heat Shield. There's other products out there, and what I like to do is, like, if I'm soldering, like there's a wire, like this is a wire right here, and I'm soldering that wire, and I think my solder joint's going to go like right about here. I'll put that heat protected compound right up to the margin of where that's going to be. I don't want any wire sticking out of where I want the solder joint to be. Because if it is, let's, say I had the heat protected compound right here, and this wire is like freestanding from here to where the solder joint's going to end up. There's no solder over it, and there's a good chance, unless I really watch my heat, that that's going to get too hot. If it's too hot, then that wire is just not going to have any temper to it whatsoever, or it'll be greatly reduced. So heat protected compound, I love it. It really works. I put heat protected compound on me one time on my finger, and I stuck a torch to it to see how long it would take before I burned myself. It takes a while. I live in Tennessee. Okay, so we talked a little bit about the porosity, subsurface porosity. If you heat solder too much, it's going to bubble on you, and you've ruined the solder joint. There's not much you can do. You can heat it and knock it off. You got to redo it again. But what you're doing with solder, once again, we're doing a regraining of it. When it has the grain structure, it's like a crystal. It's like putting water and salt. It's got a crystal structure. It's like little bitty crystals. You can put water in there, and it disassociates is what it does. It doesn't chemically change anything. It just disassociates that grain structure. And then you can evaporate the water, and you get a whole different crystalline structure. You get like a sheet with cracks in it and stuff, instead of all these little particles. So it's disassociation and regraining. The same thing, basically, it happens with the metal. When you melt the solder and it cools, it regrains. Now, if you do that over and over and over again, it's going to make it brittle, and it's not going to be a good solder joint. So the ideal solder joint is to, first of all, cover the entire thing. It's kind of like painting it. I like to use a probe, and a probe is just a wire, and I will get some flux on it. We'll talk about flux in a second. Get some flux on it and put a little solder on the end of it so that it doesn't carbonize when it hits the heat. You can just put flux on it, and that'll help keep it from carbonizing. But and carbon's an anti-flux, so if you get carbon on it, solder's not going to go to it at all. So I get that little probe, and then I heat the solder area. And if I have put a little dollop of solder on the probe, I can use that as my initial solder. I like to take soldering in 2 stages. First stage, and I'm going to have 4 clinics tomorrow, little 20-minute or whatever they are clinics. And I brought some stuff with me. Priscilla brought a torch that I can use. The airline wouldn't let me take a torch. And I've got pliers and wires and wax and stuff, and we can just play. Any questions you got? You want to see me mess up a solder joint? We can do that. So I'll show you hands-on what I'm talking about. We'll do that tomorrow. and it's an opportunity for me to talk about my video thing. So you'll have to put up with a less than 5-minute pitch, and then I'll answer any of your questions. So I take that probe, it's got a little bit of solder on it, and I'll put the flux on there. And when the flux melts, then the wire starts to get hot. Solder's going to follow heat. So when the wire is freestanding from the band, I'm talking about soldering onto a band. So since the band, even though it's a real thin material, it is touching the plaster model, it's going to transfer the heat to the plaster model, so it's going to absorb the heat that gets it. So it's going to take a lot more heat than the freestanding wire that's just leaning against it. So the wire is going to get hot quicker, much quicker than the band. So you got to watch for that. So I get my probe, the flux is melting, I got my solder right there, and as soon as the wire gets hot enough, I put the probe down there and touch it, and then all of a sudden the solder goes to the probe. And then I'll take that probe while it's melting, and I'll use it like a brush and just kind of paint it around the rest of the band so that I get a good thin covering solder all over the solder area. And then at that point, I will, well, this is regraining and this is cooling. It's ideal not to do this, but practically speaking, this works just fine. I'll let it cool a little bit, add a little more flux, and then build the bulk of my solder joint. Ideally, you would get it in the same melt so that when it regrains, it's all one melt. That's ideal. That's hard to pull off. I can try it tomorrow. We can try that tomorrow. So then I've got the whole thing painted with a real thin layer of solder all over. And then I go in there and just enough heat, just enough heat to barely melt the solder. And the solder will melt and melt into the existing painted on solder a little bit more until I get it where I want it. If you're really good, you can end up making this right here, where you have it just covering the solder area and not running down. If you get too much heat, it will run down. But what I like to have down here, I like to have that painted all the way up and down here with just that thin layer, and then just a little bit, and layers until you get it. If you're really good, and I can try this tomorrow, if you're really good, which I have days, I have other days, you can solder on top of solder if you got really good control of your heat. So you can start with something like this, put a solder, layer of solder, another layer of solder, another layer of solder. You can end up with solder way out here. But that's a good practice exercise to try to do that. It's really hard to pull off. And I did it in my video, and it worked. And I went, whoa, that's great. Okay. Ventilation. You need ventilation of some sort when you're soldering because the flux, I think it's boric acid they use. I forget what the chemical composition of that is. But anyway, it's not real toxic. It's not going to kill you like chlorine gas or anything like that. But it's not real healthy to breathe a lot. I just stick a fan over there so it just kind of blows the vapors away from the solder area. And I have found that I use one of these lights with a magnifying glass so I can see real well. And if I don't use a fan, say I forget to turn it off, that vapor kind of fogs up my glass. It has a reaction with the surface of the glass. I don't know what that is. It's hard to get off. So the fan eliminates all of that. It gets the vapors out of your face, keeps your glass nice and clean. Flux. What does flux do? Flux, very simply, just keeps the solder area clean, and it keeps it from oxidizing. When you oxygen is, it's got, oxygen wants 2 extra electrons in its outer orbit. And it's oxygen, you don't see it as just, oh, that we breathe, it's O2. It takes 2 of them to be stable. It's like hydrogen is looking for another electron to fill its outer orbit. So you don't see H, you see H2. Helium has 2 already in it, so you can just have helium gas as a single molecule. But hydrogen and oxygen need to have those 2 things. Now you can take hydrogen and mix it with oxygen, 2 parts hydrogen, 1 part oxygen, and it satisfies everything. The hydrogen, well, the hydrogen will wants another molecule, so we can borrow from the oxygen. And since the oxygen has 2 to give, and the hydrogen wants 1 each, so you get it works out perfectly, and then you get water from that. You can disassociate the way they do like electrolysis of water. You can disassociate that molecule in certain ways, and where you have hydrogen kind of by itself ready to react with something, and then you have the OH, which is a hydroxy, and it's ready to react with something. And those are, you see that a lot in organic chemistry, and where you have carbon compounds like methyl methacrylate, and it's reacting. And you see a lot of hydrogen and hydroxy ions going in to hook up to these chains when the methyl methacrylate goes through its polymerization process, and it starts here's the expert on polymerization chemistry right here. If you want to know about that, you know much more about that than I do. But isn't it right when you got these like grains of polymer, poly meaning many, so you got many little mers, and it's methyl methacrylate, which is a simple little compound. I used to know what it was. I can't draw it now. But anyway, so you got these things, and they're kind of chunked together, kind of like salt crystals. And then you take the monomer, and it's stable by itself. It's just fine alone. You can put it in a bottle. You can open it up. It'll vaporize. But then you mix the two together, and it starts this reaction called polymerization. It starts breaking down that powder and forming these elastic chains. And correct me if I'm getting off track here.
And crosslinker added to it causes long chains.
Yes.
And it's multi-molecule.
Yeah.
Is the polymerization, and the heat is generated, and the heat assists that polymerization process. That's why we get plastic.
Thank you. Yes, like I said, I defer to Priscilla on all of that. Sorry, I mean, she has actually engineered and gone through the FDA process and pigmentized products, and I mean, you're the dude on acrylics. Okay, they have a thing called yeah. I'm from Tennessee.
All right.
They have a thing called free radicals. I think did you anyway where you cross link, and these things the chemical compounds they put in there, they're called free radicals. They're highly reactive. They're kind of stable on their own, but when you put it in there, they get reactive with that polymerization chain, and they kind of hook one strand up to the other, and so they're kind of crossed, and that's kind of what we want. It makes for a stronger acrylic. And all these reactions, chemistry is just kind of like, if you think of it as like magnets, and everything's hooked up magnetically, and some magnets are real strong, some are real weak. If you had like a refrigerator magnet stuck in a refrigerator, it's just fine sitting there until you bring in one of these magnets that picks up the cars in the junkyard and turn it on, and it goes, hey, forget the refrigerator, I'm going over here to this guy. That's kind of how chemistry is. You got something that's stable, put something else in there, it's got a bigger magnet, and it attaches here or sucks something off of there, and that's basic chemistry. Slumping, when you're teaching people about slumping, that's just something they need to get a handle on. And your acrylics are amazing. I was back there playing with one. I really was terrible at the design thing, but I could see how that would take some work, but I could see how you could do it, and watching you with your expert skills. I mean, that was phenomenal. And you really worked this thing out where you made it simple. I mean, being an industrial professional, I appreciate that.
It's for being a lab tech.
Yeah.
You know, gotta build a better mousetrap.
Well, you did indeed. And I was amazed at the low porosity of these acrylics, because like you said, it gives off heat. It's an exothermic reaction. When it goes on, it gives off heat. Some reactions absorb heat and they're cold when they go on, and some give off heat, like acrylic and like gypsum products. And it's just the nature of the reaction itself. So when it gives off this heat, it also gives off bubbles. It's a gas, and you don't want to breathe that gas. You want to have that in. Well, we did a little bit. I mean, it can be diffused, but if you're doing it a lot and you're there all day long, you don't need to be breathing a lot of that stuff. So a simple exhaust fan of some type that uses an activated charcoal filter. I had a guy build. I was saying, I want this and this and this. I was going to have him build this thing. And then he looked at me and said, why don't I just get an oven hood and build a thing around it that makes it like a chemical hood? I thought, duh, that's pretty simple. They come with their own activated charcoal filter. So you stick it up there and you turn it on. It's got a built-in light. So I got a chemical hood for like, I don't know, a couple $100. Or you can get like something as simple as I've used like one of these like work pan things with the motor in the back that when you grind and it sucks the things, and you can get an activated charcoal filter and put in there. It has to be activated charcoal because it's carbon, chunks of charcoal, and I don't know what the activated means. I used to know, but I don't remember. But anyway, it makes it highly reactive to things like methyl methacrylate vapors. So So they go through there and it doesn't just filter them, it chemically attaches to the carbon and it takes the stink out. It reacts, it changes its nature. So it's no longer methacrylate vapors anymore, something different. So that's really cool chemistry. So you can just, anything that sucks, the vapors through an activated charcoal filter will eliminate that. You're having to breathe that stuff. Why a pressure pot? Did you do something to the chemistry of your acrylic to make it have a low porosity? I mean, it's exothermic. I felt heat. I mean, it has to be exothermic. But how did you do that? What's the secret? Is it a trade secret or something?
Well, I think primarily the trade secret is the fact that I played around with the particle size distribution.
Oh, okay.
And so my formula is unique, different than anybody else's out there because I've gone to the manufacturer and I said, for me, this is kind of what I want. Now, if that allows the monomer to wick every grain, not cause it to slump, and it can cure at room temperature without pressure, without the porosity. My experience with that is the finer the grain, it's more difficult for you to get it totally wet. And sometimes I believe those bubbles that you have is where the polymer isn't married with the monomer at the proper ratio. And you have an imbalance of polymerization. Molecules are giving up and taking electrons from each other, and you've got something left over, leaving a bubble.
Right, yeah. So you go with the finer grain, or do you go with a more coarse grain? You have found the right size grain.
And the ratio.
Okay, the ratio of the liquid to the
All,
powder?
no, the ratio of polymer. There's like, polymer is rated like oranges and apples. There's select and there's
Oh,
premium.
I didn't know this.
And bead resin is manufactured now, so there's a certain distribution of particle sizes of the same PMMA
I
in
did
the
not
same
know
batch.
that. Wow. So when you buy cheap acrylic, you're really buying a lesser grade particulate.
Yes,
Okay.
it is an industry standard. Industry standard did not meet my characteristics that I wanted.
Wow.
And I struggled with that. And you've experienced it. You get a batch of polymer from another vendor and it sucks. And it sucks until you're done with it. And the next batch might be better, but you go, well, why is it different from the other batch? And so, having been a technician, I experienced that myself. And as I worked it and then got into the manufacturing and added pigments to it, their characteristics of what the industry standard is feeding me didn't work all the time.
Yeah.
And so I made my own set of sieves and would play around with particle size distribution. So I'd sieve it all out. I'd have 9 different sizes of particles, and then I would just feed certain percentages back into a batch and play around with that. And then when I got the characteristic that I wanted, I took those ratios to the manufacturer and said, I want my own blend.
So you have a
I have a
company
proprietary
that makes it
batch
the way you
and-
want it. Man, that's great. You did some real research on it. Yeah, I had no
research
idea.
was working the bench.
Yeah.
Trial and error. And
That's research
thinking
there,
outside the
isn't it?
box.
Yeah. That's great.
So if that's why there's no porosity, that is my take on it.
That's great. These things I hadn't thought of. So, yeah, bubbles, why we use the pressure pot is even, do you find that if you pressurize that you even get a more dense?
More
finish part?
dense, more clear,
Yeah. So there is-
definitely more clear. So
But-
the heat.
Yeah.
Cold cure resin is called chemically activated acrylic. We all know what heat cured is. You can mix the powder and liquid, it'll stay doughy for 2 weeks.
Yeah.
Have to introduce the heat for that to do what it's supposed to do.
Yeah.
Chemically activated or cold cure resin likes the heat that you have in the pressure pot and pressure, accelerate or intensifies that heat inside the pot. So the polymerization is lickety split out the gate to the finish line without any kind of interaction. So it's a full, fast chemical, catalytic reaction.
So you're looking at the pot as more of a expedient
Acceleration.
accelerator of the polymerization reaction.
In the pressure pot, my resin can come out in 5 minutes
Wow,
and be ready to be ground on.
wow, that's amazing.
Bench setting, it was setting here, I don't know, probably about 8, 12 minutes.
That is amazing.
So,
Yes,
I've used her material for what, 20 years,
yeah,
25 years?
17, 18.
That's why I use it. I don't use anything else.
Yes.
All I've done since I discovered her material, precisely because of that. There is consistency in what you're doing, and my clients appreciate it, and I love it.
Yeah.
It's just the best. And that's because all the hard work she's put into that.
Oh, yeah,
But you
yeah.
can see it.
Yeah.
And this last sentence that she said, it's out of the pot, and in 5 minutes you're ready to go.
Wow.
It's a lifesaver, especially if you have 50 things you gotta do.
Right.
And you're boom, boom, boom. And then you're consistent with it because of what she's done. You can rely on that. So my day goes, I know what to expect on a daily basis, and then I'm managing deal with that. But that's what it brings to, so I can process more, I can do more because of what's there. So yeah.
Consistency, who would
Yeah.
think? Make a consistent product. Do you still pressurize?
Yes, and it's right, it's true, because I've done it both ways.
Yeah.
And the clears are clear,
Yeah.
but it's because of the pressure and and it's a quick process.
Yeah.
And you don't lose the quality and consistency. And it's so see-through.
Yeah.
You white's off.
Yeah.
And it's a great.
It's beautiful. Yeah.
That's a great. It's
Yeah.
very good.
So Jay,
Yes.
maybe this is for anybody here too, Priscilla. Have you seen a difference in how you cure the acrylic? Whether you're using a humidified environment, with the pressure, the heat, versus the submerging it in warm water.
Yeah, I heard you brought that up. Yeah.
Now I notice, and I can probably say this safely, I think with Priscilla's acrylic, it would be a humidified environment. But I've noticed that with acrylics from Great Lakes or maybe Dentorum, that depend if we were using their splint material, that we would get a better result if it was humidified. If it was submerged.
Yeah.
And then with some of the other acrylics from other brands, we would see it pull away from the cast, and we would have this, microscopic, space we would see, and there would be warpage or shrinkage of the acrylic.
Yeah.
And so, we had a lot of those problems with a lot of other acrylics until we switched over to Priscilla. So
I guess you worked on that shrinkage thing too.
Well, what I found, and I hate to speak poorly of my competitors, but a lot of them, their products has been repackaged for them, private labeled by another repackager that for the most part buys materials from maybe 3 other polymer manufacturers in the United States.
Wow.
Each of those companies probably have a dental resin standard. So the powder can come out with certain chemicals in it that makes it react for our application with a high range and a low range. And it can be any of the above. So it can be somewhere between the low range and the high range. So if you get a batch of polymer that is on the low range of chemical that is activated by the chemical or the monomer. Who's making the monomer? Who's adding the special chemicals to the monomer? Is that somebody else? Is that 3 other companies? And so, let's use Great Lakes. Great Lakes buys their resin from Lang, buys their resin from the same company that I do. But what are their standards? They only repackage for Great Lakes. Now, where does Lang get his monomers? I don't know. Are they a paired system? If someone's getting powder from over here and monomer from over here, and now they're just brought into Great Lakes distribution house, and I get a pound of powder in a bottle of liquid that now I'm putting them together. And powder's got a low range of the accelerator, and the monomer's got a low range in the activator, and now they're both trying to get out the gate at the same time to get that polymerization done, and they're looking at each other going, where's my heat? Or they just open the pressure pot, and I'm not done cooking yet. And so you have acrylic that's not doing what you're expecting it to do. And the next batch, the powder could have a medium ratio of chemicals. And another then batch of monomer that for whatever reason 6 months later is now paired with that powder, and it's kicking off really quick. And someone's going, I can't even get through a pour before it's too hard. So that inconsistency, and people say, well, I've had problems. What is it? Because both my powders and liquids come out of the same house. They're always a paired system. I know what the value is of my powders and the chemicals that are in them, and I make my monomers accordingly to marry with that chemistry system. So does that make a difference as far as pressure potting underwater? I never got good results with Great Lakes materials, Dentrums. When I started making my own, I'd already moved away from submerging. I get bubbles, it's more time investing to have outgas all the models, blow them off, separator wing stick, wax wing stick. So I steam, still in a pressure pot, above the water.
Yep, when you say steam, you put just a small amount of water in the bottom, that's
Just
hot
enough,
water?
just enough water to
Yeah.
carry the heat.
Yeah.
And then you put the
Pressure
bottles on the rack,
Yeah.
close the lid, they're still at 105, 110 degrees temperature inside the pot, 20, 25 pounds of pressure.
Yeah.
In those conditions, you can remove that bottle in 5 minutes.
That's amazing.
If you go into that pot before that 5 minutes, that's like opening the oven door when the cake is baking.
Mhm.
It might fall.
Yeah.
So I recommend if the lab is busy enough to where they needing to go back into the pressure pot in under 5 minutes, get them another pot,
Get another pot, yeah.
get another pot, and then multi-pot.
That solves a lot of the issues in my lab when, for Brazil, and then I mentioned that I had to that, Brazil was at two top pots. And then so it's not a second pot and it's not the whole, like, issue. With, the things lumping, all that.
You know, Priscilla mentioned a couple things. We talk about scientifically, the pressure, the pot, the heat, and the pressure. How does all that work? Well, pressure and heat are directly proportional, and which formulaically that would look like, pressure 1 over temperature 1 is directly proportional to pressure 2 over temperature 2. And so if you had like, say you had atmospheric pressure, I don't know, we'll just say 15 pounds of pressure, and say it's 70 degrees. Okay, this is the atmospheric pressure, not the water temperature pressure. Then if you crank up the pressure to 30 degrees, then you would solve for X, what's it going to be? And you cross multiply, and then you would divide that T into it, and it's just simply, it would just double. So if it was like, if the temperature was like 70 degrees, it would become 140 inside the pot. Like when you, like the old days when you have a flat tire and you start pumping it up, to pump the thing up, it's not necessarily friction, which does add some, there is some thing here, but mostly it's the pressure. It really, what happens is it just squeezes those molecules together and they're bumping into each other and they give off heat. So That's one of the things that's going on inside of the pressure pot. Now, another thing, I said it's the temperature of the atmosphere, not the water. So if you do submerge it, and then you put pressure in there, it's gonna increase the temperature of the atmosphere, which will eventually increase the temperature of the water, but not directly, not like, if you have it in an atmosphere. One of the reasons, for submerging it is that, like you mentioned, degassing the model, where you just, force all of the air out of it. And then, if you have, lukewarm water in there, that temperature will expedite the polymerization reaction, but so will the steam, or the, increase pressurizing the aqueous, gas that's in there, the watery gas that's in there. So, yeah, these are all interesting things. So once, somebody understands the science of it that you're teaching, then they will understand why maybe you don't want to dunk the model, you want to pressurize it, or, you just understand what's going on. So if you're using a really crappy acrylic, you might want to degas the model and submerge it. If you're using a quality acrylic, it will work best in an atmosphere that's pressurized. Another thing to teach people about acrylics, how am I doing on time here? It's 5:25. Am I supposed to finish? I thought I was going to finish, but
There shouldn't be much cake, and I'd be
Okay.
sure that.
Let me wrap it up and see what I got here. Oh, okay. Perfect. Great. Real quick here. So when you're teaching grinding, polishing, trimming, and all that, they have to understand that when you take an abrasive to an acrylic, it generates heat. And you'll see people, just, all of a sudden your acrylic doesn't fit against the model. It's warped. So I had a guy, he was, bless his heart, he was from Russia, and he was a dentist in Russia. And then he couldn't find a job over here because he wasn't licensed. So he came to me, and I needed a finished guy. So I said, well, he knows how to do dentures, so surely he can polish acrylics. Well, he would just grind and grind. Those things would just come up warped, and then just like, and he would polish and just, he really wanted a slick, high shine. That was his goal. But in so doing, he compromised the integrity of the product all along the way. So it's not necessarily the high shine that you want. You want a high shine, yeah, but you want to understand the science getting into the high shine, so you don't mess it up. All right, here's orthodontics for crown and bridge guys. How many crown and bridge people do we have here? All right, do you work with implants? No implants, okay. Well, I learned this just recently, and I think it's just one of the coolest things I've ever heard of. You probably know all about it. A lot of stuff I don't know. But if, let's say you have this doctor had a first bicuspid, missing a second bicuspid with a sizable saddle area, and he had a first molar. He's wanting to put an implant in there. And he thought, well, I'm going to have to do a bone graft and build that bone up. It's going to have to heal, and then I'm going to put the implant in there for the second bicuspid. And then this guy said, why don't you just move that first bicuspid back orthodontically? It will build bone as it moves. Then you will have that nice non-saddle area where the first bicuspid was, and put your implant in there. Is that not cool? I think that is just cool. It builds bone as it goes, and so you got that bone there already where the first bicuspid was. I love that. So that's how orthodontics can help, a crown and bridge person. See, another thing, you can use aligners of whatever type to make the alignment of the anterior teeth straighter, closer to where it should be before they do a restoration, whether veneers or whatever. I do a lot of things like that. I get things sometimes where they'll have a bicuspid that's got space to be buccolized. Maybe it's in lingual version. You want to buccolise it some so they can put a crown on it. And so we just make a little simple gadget with a spring and it just kicks it out there, and everybody's happy. So there's a lot of application for orthodontics in the crown and bridge field, and I'm sure you can think of other things. We're about to wrap it up. Crown and bridge people, use your local orthodontic labs. Use them often. Yes. Routine. Yeah. So I'm done. I'm going to be at the. I have it's booth number 19. Come by. I'll tell you about my video project. I'll have flyers and things. We can talk and play with things, and let's just have some fun tomorrow. All right. All right. Okay. Thanks. Appreciate it.
Jay, on behalf of the dental General Laboratory Associate of Texas. We'd like to give you our gift and a certificate.
Thank you, Ernie.
For everything you've done for us.
Appreciate that very much.
I'm gonna scan you on your way out if you'd like. Please remember, I think we have the Women in Dental Technology mixer going on. We also have a mixer going on with the attendees down there, and then they have the whatever, the laugh off or whatever it is tonight outside on the grounds of the hotel. So,
Mark, are you gonna be doing?
no. Not me.
See you tomorrow.
Okay. Sometimes it has to.
Well, I think if you probably.
Ended and it's not letting me do this.
Get this checked out tomorrow.
What happens sometimes?
Let me see. I need to get with Kay to get the password.
What happened at time's up after the class ended? So,
Yeah, well, I don't know. Let me see. Try this one more time.
are we good if we sign the book?
Yeah, we should be, but this will. You go back.
Good for you. Yeah.
We need the override, so if there's a problem, you guys have your slips and you've signed
We
the.
signed the
Okay.
book, yeah.
Then I'll let Cade know we've had a problem with the override again, like we did last class.
Okay.
And
Okay.
again, if there's any problems, I guess we can clear it up with the NBC.
What happened?
Thank you.
Thank you. Yeah, it's override again, these things.
Not working.
Oh, no. But then I'm gonna say I
Yeah, I
went to
don't
like
know, you
5
know.
different classes.
I don't know. That's what happened last time too. But you signed the slip and everything?
Well,
And then did you sign it?
Oh, yeah.
Okay, good. Then you should be all right.
She doesn't know her, she might call back, she'll turn around and look at me and go.
Thank you very much. Yeah, and it's good when all the technicians are.
Oh, yeah.
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 You always learn somebody.
Oh, yeah.
And it's like the override again, so yeah. Yeah, you have the paper, right? And then. Yeah, oh, you know what? They didn't have those on the MSC. So we scanned you on that, and then you signed that form. You signed the one for the acrylic, and you signed for the one right now.
Yes.
You're good then.
I can't believe that they, like you said, I can't believe it's up in the pressure. Taking it out, and it's still, the color is still uncooked.
It's not, we gotta do the override again, yeah, so.
That's.
You signed the paper, right? And then you also have your sheet for this class today. So you should be-
I gotta learn to use the other stuff too.
Yeah, it worked earlier, but we didn't have a sheet.
The separators.
But you might,
you don't submerge your models and you use it.
No, I don't, no, I use, I use Pentagon all the time.
You know, that's one key.
But it's when all people use trainees.
Yeah, oh, yeah.
So I said, well, let's try submerging it.
The 707 CC. The 707 CC.
Oh, that's I don't understand, but I guess. I figured, yes, something.
Did you have certificates for this one?
The little slips? You didn't get it, right? Yeah.
Well, Chris.
And the scanning is not working on this.
On this one?
No, it's not working.
Thank you.
We're on the phone with so many damn times. What is that number? It's, 2170? To order.
Yes, 2170 is item number.
How much are they?
I think about $50 for a pack of paper.
They're in here? I'm gonna take it to the people department and show them, because I think it's state.
Oh, yeah.
And then even for my technicians, you know, when they're picking them out of the bags and everything, they gotta handle them and wrapping them in, those staples are just like,
Oh, yeah, I know, I've gotten one myself.
no, it's not safe, that's not safe at all. Because even though your lab slip says, in this case, we disinfected, I'm hoping that they're being truthful, because we're gonna have to disinfect it anyway.
I failed, because I get asked the same thing, I'm like, yeah, I put it in. I was here, you want me to take these and send them out to my doctors.
Well, they're meant for that, so if you've got 9 doctors.
I'll tell you what, I'll think about the doctors, I wanna take four for right now, because I know absolutely four that definitely need.
That's fine, yeah. Whatever's gonna make your life easier.
Yeah. Well, and also it might sell.
I have a lot of them, yes.
So you only put like one, you don't put one on the.
Worked on my non-school signatures. No, no. Yeah. You only have 2 cells and also. Right. And my more expensive customer of mine, average, with the straight leg component, or each other, so everywhere he goes, he keeps make sure that the orthodontic office buys my resin. Anyway. Conversation.
Wow, just
You
one.
know, I did look on. I thought, the only, I'm not.
Well, as soon as I saw it, I went, oh,
He said,
yeah,
no.
that's, you can look at that and go, that's the mousetrap right there. That is the better mousetrap.
So,
Is there any?
I think we trained. Long.
Right. Because I just don't think that this is the one to do. Do you wrap them up or anything?
No, they were just in there. Oh. She had.
Layer, just put a layer over it.
Well, that's why I'm saying.
I know.
I'm talking about that as a.
Well, that's by all means, because that's what they were just, they're not doing anything, they'll do you good if you get your guys doing it.
You'd like me to help you, you need to do anything?
Well, it's kind of, things aren't gonna go back in the box unless they kind of go back in the box, go out of the box.
The way that, okay, so.
So, but you're well, if you wanna help, then, maybe
Sort of
the monomers will go in here. And then the hydrometers.
Is this gonna be headed project Monday?
Yes, sort of the sound.
Actually, if I get it put on back in the boxes, right, it just might go up for next year.
Oh, there you go.
There are some
Put
open.
just put the lid on.
In there, there's a plastic tub. That had tools in it.
That's the word.
You know,
Yeah, I think they should take that. That's Kane. Set it up. Oh, my. Hey, we're on TV.
oh, I got something else.
Oh,
No, it's